Okay, we're on. We're live. No more bad. No bad. Okay, so LS to show you directories, CD to go into a directory after the name. So you type in documents. You can press Tab to go to auto complete something. So right now I type D. It all completes desktop, documents, or downloads. So I'll type a little bit more, right? And if I press Tab, it all completes it. What command is used to have root privileges?
How would you get there?
Okay, for you, Kieran, you see in the top left, you see these icons up in here? Press go to that one. The one that kind of looks like a terminal has a dollar sign.
Next to Firefox?
No, the one next to Firefox. And yes, you're right, it's sudo. Sudo is to do every command have root privileges. Alright. What is command to read the contents of a file? So to read the contents of a file, you'll type in cat. And cat stands for concate, I believe, or something like that. So if I wanted to read the contents. Okay. What's another command? How do you show your directories inside like a tree hierarchy? Where it looks like there's branches coming from each directory.
I think it's tree, and then whichever one you like number.
Yeah. So if you just type in tree, right, it tells you it's at your current directory, right? That's what it's showing at your current location. Now, how do you get rid of text inside your terminal? Clear? Yeah, perfect. Okay. How do you make a file? How do you make a new file? What's the command for that one?
Control C, Control V.
Control C, Control V.
You have to press Control Shift C.
Control V and Control C are different here.
Yes. So to actually copy.
To do it, you do the Shift with Control C.
So to copy something, you actually have to press Shift Control C and then Shift Control V to actually paste it. It's different because Control C actually stops the process. So to make a new file, you'll type in the name of you type in touch and then the name of the file plus the extension, and that will create a file as you can see right there. And what's the command to remove a file? Does anybody remember? The command to remove a file is RM. RM stands for remove. So then boom. Does anybody remember how to delete a directory? To remove a directory that is empty, you'll type in rm dir, and dir stands for directory. So here's the thing: if I were to remove downloads, right, it won't work because directory is not empty. You cannot delete a filled directory. No. If I were to go into downloads, for instance, you can see that there's files in here, and I can't actually delete them.
Now do sudo rmdir.
Now I'm not going to do that because I actually don't want to accidentally delete downloads. It might work, it might not, but to delete for certain, to delete a directory, you'll do the parameter -r. Wait, hold on.
rmdir.
You use the parameter -r to delete a directory inside your file system. So if I wanted to delete downloads, I'll do rm-r downloads. Oh shoot, and I don't want to actually do that. But that's how you'll delete it if it's filled. ABT is used for downloading apps or applications from the internet. Usually there isn't a difference between ABT and GET. I believe APT GET is just a more up-to-date version, while ABT is an older version. But I use them both, and it doesn't actually matter which one you use. One thing I forgot to mention, probably from yesterday, is the dots. So when you use, correct. When you use dot, it takes you a hierarchy up. So if I use dot right now, you can see that now I'm in the home directory before I was in my current user directory in the home. So obviously these are my users in here in the home. So if I CD back to Cali, right, you can see that now I'm back into the Cali directory with that little hyphen symbol right there. What's the command to use to show the command to use previously before? To show a list of the commands you used before.
Rev. History.
History, yes. Okay. And last one for Kieran. What's the command to change your password? So Kieran, for you, type in the command passwd, stands for password, and press enter, and you'll be able to change your password from there. Alright, one last thing before we go into our lesson today. So does anybody remember how to go a command up? Like what kind of key it takes to go through sift through the commands?
Up, arrow key, up.
Arrow keys, yes. Use the arrow keys, and that's how you'll be able to sift through the commands that is being shown here. Alright, let's get into today's lesson, I guess. So today we're going to be learning about programming. Programming is writing system code from a language for the computer to do specific tasks. Okay, so the most we're going to be doing for programming and here in this whole cybersecurity club is going to be Python and C, right? You guys, you might need to learn, some other languages, but usually when it comes to programming, you just need to learn one language and learn it really well. Then you can learn it any other language because most languages are the same. Like for instance, Python, C, C++, Java, whatever. I mean, granted, their structure is different, but in general, they have the same concepts. So if you guys can just learn programming really well, you'll be able to learn any programming language. Okay, so with programming, there's variables, and each variable has a different type of value. For instance, we have int, which is an integer. That's a number value. We have string. That is a set number of characters. Also, you can see the examples over to the left and colored in green.
Wait. Yeah, I have learned Python.
I know those first.
And we have float, which is a decimal number. So with each of these, for instance, integer, it has to be a whole, everyone knows math, right? Whole numbers?
Yeah.
So it has to be a whole number, right? It can't be a decimal number or a fraction or any of that jazz. With strings, it has to be a full set of characters, and with a float, it has to be a decimal character. It can't be a whole number. It has to be between 0 and 1. And of course, there could be negative values as well. And there's also one other variable, and that's booleans, right? Booleans, it's not that hard. It's actually really not that hard. It could be a number between a number either 0 or 1 that's true or false. So with booleans, false equals 0, right? And true equals 1. Eventually, we'll have to learn more about between zeros and ones and how true equals 1 and false equals 0. But we'll get to that a little later. Another character I forgot to add was the char variable. So the char variable is any character. The char stands for character. So any character in the alphabet, right? A through Z. Another variable that we'll have to learn about is the null and void, and these are just unassigned variables. If you actually pulled up a program to see a value of null or void, it will just be 0. It won't be any value. It's just a placeholder to find the whole value.
Like zeros and ones pretty much is all it is.
Yeah, except with null and void, it won't be zeros and ones. It will just be zeros. And that's just a place value. At some point, you might see this.
It's like the zeros before the actual number and a decimal. They're just placeholders.
Yeah, placeholder. Yeah, correct. Placeholders, just to assign a value to it. All right. So there's some different data structures when it comes to programming, and the first data structure are tables. So a table is a way to define an object into a language. There's also dictionaries, which are unordered pairs of values. Let's look at examples instead. Alright, so with the table, we have our variable that we're calling it on, and we're saying it equal to these value sets. So, for instance, let's say you wanted to make a car object, right? You'll define the whole variable, for instance, car object, and then these are your attributes that you use for the car object. So, for instance, speed is equal to 4, the type is a truck, and if it can do this, then set it. But that's what it does. So, for instance, if we were to actually print out this to see the value of what this is, for instance, .speed, it will print out the value 4 for the speed, since it's an integer. So another thing about that structure is a dictionary. So with the dictionary, it's like setting these values, right? And being able to call these values based on what you call it on. So for instance, there's a call value of 1, 2, 3, and 4. And what each call value corresponds to is what's after this. So for instance, 1 corresponds to this, 2 corresponds to is, 3, a, 4, dictionary. And if we were to actually run this command right here, it will output this because the command here for 1 is the value this. And that's kind of what was before we had in this here. So a dictionary is the values and they're initialized by a key. Last thing is a list. So with a list, it's kind of like a dictionary, except you actually can't call to the values based on a key. You call to them based on the index. So each value is based on starts at the index 0 and goes on to infinite. So here, value is the index 0, this is index 1, and this is index 2. If you can see that if we call index 2 on value list, it prints out fast. Later on we'll talk about more about indexes, but the reason why indexes are a thing is because of data storage in memory of computers. If you actually look up the storage on computers, you can see that each memory is allocated by indexes. Alright, some other things about programming with the object lists are arrays and tuples. So arrays are the same as lists, except they can only store one data type. Now, I'd like to mention one more thing. With variables, there's actually a lot more than what we said in the beginning. Like, there's more than just integers, strings, floats, booleans, and characters. There's way more. I mean, ridiculous amounts. There's ulong, which... Okay, I'm going to say one. There's too many to count, but ulong, spelled U-long, right, is a set of numbers between a really long amount to a really short amount. So with arrays, they're the same thing as lists, of course, but you can't define a different type of variable, right? With an array, you can't define an integer and a string in the same value. So we're going to talk about tuples. So with tuples, you have to define the values of a tuple, and the thing is that it's the same as a list. So you can define any values inside of it, but you can't change it the moment you run your program. Like, no. Once it's defined, you can't change it anywhere else in your program. So for instance, if I want to add a value like orange to the tuple that I set here, it will not work, and it will say something like too many values to unpack or something like that. So when we're writing code, there's a specific type of format that we need to write it as. These are camel casing, snake casing, Pascal casing, and a macro casing. So if you look at this, you can see that camel casing starts the first word lowercase, but the second word casing is uppercase for its first letter. And same with snake casing, you can see that snake and casing are separated by an underscore. Pascal casing, both words are uppercase for its first letters, and macro casing have all uppercase with a underscore in the middle. So the reason why we want to do this is so we can... Has anyone heard the term readability in code?
Yeah.
Okay, so readability in code is how well someone else can read your code without having too much struggle in it. And well, formatting it doesn't really increase your readability in some sense, but it does make it look nice and neat. And for some instances, like naming a variable, it has some meaning if you have camel casing or snake casing for naming it. So camel casing is used for naming variables, right? Naming integers, strings, booleans, stuff like that. And you'll want to name, of course, the first letter lowercase, the second word uppercase. Snake casing is the same as camel casing, except I would recommend you guys using camel casing, right? It's much neater, it's much nicer, it looks a lot better too, in my opinion. But it's up to you. If you want to use snake casing or camel casing, it's up to you, but it's the same. It's the same as camel casing for naming variables. Pascal casing is used for naming data objects and classes and stuff like that. So, and some people also use it for functions too. So you'll want to use, so with passive casing, you'll name your first word uppercase and your second word uppercase as well. Macro casing is used for naming a variable that doesn't change or is constant throughout each file or program. So obviously with macro casing, all letters are uppercase. Alright, now we're going to get into functions. So with a function is a way to store multiple lines of code into one data set. So for instance, if I want to say, if I want to call integer multiple times, I don't want to have to say, alright, call the integer value every single time. Instead, I'll call the function example function, or something like that, and it will call the values inside that function every single time. There's a way to write code. It's called, oh, dry. That's what it's called. Okay, so dry stands for do not repeat yourself. And what that means is you're not going to want to write multiple lines of code that are the same when you could just put into a structure like a function. So that's what functions are used for, and it makes writing code easier. So with functions, there comes parameters. And a parameter is a way to store a value inside a function to be used later on inside the function. So if you can see here at the parameter param, it's being passed down to value. So in this case, if we call the function and have the value 1 will go into param, which goes into value. So if we were to print out the value, it would print out 1, because that's what we passed into that param function. So an argument. So an argument is basically the value you're passing into a parameter. So if we have param 1 and param 2, the example function 1 and 2 are the arguments to be passed down into the parameters. And you can call multiple parameters by using commas. Some programming languages do things differently when calling parameters. So with this case, it's commas, but in other cases, you might have to specify what kind of parameter you're using. We'll learn a bit later on that. So scope. Scope is the range of where your program exists. So there's two types, global and local. And with global variables, it could be used between files and inside functions. And local can only be used between the space that it's given, between its range. So let's take, for instance, this. So we have the global variable, G variable. G stands for global. And we have the more local global variable, int s variable. So the global variable can be used between files, between its program and between another file. The s variable can only be used between that file, but it can be used anywhere inside that file. So for example, we can use the variable s variable, call it in the function, and also print it. And with global g variable, we can use that variable inside another file. Alright, so one other thing about local variables. Local variables can only be used where its scope is. So local variables can only be defined where its scope is. For instance, I'm defining a variable x in function, so the variable x can only be used in function and not outside the function. So if you were to try to call x, it would say that x isn't defined because it can't find it. Here's a better representation. You can see that this x is inside function, and when you try to print x outside the function, it doesn't work. We're going to be learning about statements. Statements are ways to do events in your programming language. So for instance, there's the if statement. So this statement commits an action if the statement that it's running on returns true. So right now, I have the statement if. If value, then do that function. So it's seeing if value is true, and if it is true, then do the rest. There's also another one called an iterative loop or a for loop, and that will do a certain amount of functions a specified amount of time. So for here, we're doing for I in range in range meaning between 1 and 100, will print I. So this will print 1 to 100. So the last one is the while loop. So a while loop continues until a specified value returns false. In this case, this while loop will run forever because it's stating true. True will never return false. So while true prints while the while loop. But this one will keep on infinitely, and eventually your program will crash because your processor will be overloaded with the amount of processes that it can do. So if you're ever writing a while loop, make sure you know that it'll eventually return false or it'll end eventually, because if you don't, it will keep running on into infinity. Okay, so with this first program that I made, right, it of course is specifying our values. So x is a 5, which is an integer value. Y is a string. All right, and with z, or a boolean, yeah. And if you run this, of course, it'll print out 5, cyber, and true. Okay, another file that I want to open is the data storage. And this is, of course, what we were talking about with the dictionary. So obviously we have the dictionary key value of 1, which is example, the key value of 2, which is dictionary. If you want to run a file, you would do the command dot slash and then your Python file. So if I did data storage .py, it will run the file. But does anybody remember why I can't just do that?
Me.
Do you remember the permissions read, write, and execute?
Yeah.
So with reading is reading the contents of a file. If I don't have the permission read, I can't read the contents of it. The permission write allows me to write content to that file, and the permission execute is to execute that file. So to have permission for an execute for a file, you'll need to run the command shaman plus x. So if I do shaman plus x, data storage.py, and then I type ls again, boom, now I can actually run the file because it has execution properties. So if I run it, alright, the thing is about with Python files is that you can't just do // because right now the / is mainly used for C files, I think C++, or it has to do with how our architect here on our laptop is used. If you guys go up really quick, go to Firefox and type in GCC, which is our, so right now we have this is our compiler. The GCC is the compiler for the GNU compiler collection. And it compiles like C files, and I'm not entirely sure what all the files it compiles, but generally a lot of them. But the thing is, it can't compile Python files. So to actually run a Python file, you'll type in Python or Python 3. I would recommend using Python 3 because it's more stable and up to date. Python is just, I think, version 1 or something like that. So if I type in Python 3 data storage.py, it runs it. It runs it smoothly. Colon is only, so with colons, as you can see down here, that's only the commands, that's the functions you're able to do. So I can do the command Q to exit out of NVIM, the command W to write files, and the command, so to actually edit a file, you'll type in I without the colon. And right now I'm in insert mode, so I can type whatever I want into insert mode right there. Let's specify a file. Let's specify a file to create. So let's type in NVIM, right? And let's just do cyber.py to edit a Python file. Cyber.py, py for the extension. So let's type in NVIM and cyber.py. So everybody type in the command def, And if you look at it, does everybody find these snippets down here? You see def snippet. So if you can see here, we type in def, and does anybody remember what def was?
Define?
Yeah, define. Yeah, perfect. Define. So define is used to define our function, right? You can even see here in our snippet, it says new function. And what's actually neat, what actually is neat about this, is if you didn't have these, it might make programming a little bit harder. So I decided that, hey, why not have some code snippets to make our lives a little easier. So right now, if you go into your code snippet, it's going to have you to, so if you guys go into your code snippet and you enter that, it will ask you to rename that function. You can name it whatever you want. So I'm just going to name it example. And of course we have our argument for our parameter. So parameter was a way to call that value later on into your function, to pass the value into your function. So if we go in here and we type in integer, right? Well, actually, what's nice about Python is that you don't have to specify what value you're talking about. So you can just type in your variable, and then we can equal that variable to anything we like 5. Alright, so everybody type in that, and since our parameter is already made, let's just assign parameter to our variable. And if we call this function, so example.com for me, and we can specify our values inside our argument to be passed down to our parameter arg. So let's say I want to do the naming of 69420, right? And let's, yeah. And now, if I wanted to, I can also print.
Legendary.
There's some other functions and methods that you can use. So I can print variable, and it will print the value 69420, right? Yeah. Okay. Well, now let's do the if statement. Let's do the if statement. If we do the if statement, variable equals 69420. Then we can do some other commands for this as well. What do you guys want to do inside this? What do you guys want to do inside our if? I want to get rid of all this real quick. Let's make a for loop that counts a certain amount of times and put those values into a file. So let's do the for loop for I in range of. Sorry, we got rid of all that. In range of 1 to what is that?
10,000.
10,000. Oh, one thing I want to mention. Remember how your indentions are done. So if you can see here, we don't have an indentation here, but when we're doing statements and we're doing new lines of code inside of functions, you want to do indentions. And what's weird about Python?
They will automatically do it.
Yes, for some things they'll automatically do it. But if you, let's say for instance, I accidentally got rid of that indentation, well now you gotta realize that you have to make that indentation. What's weird about Python is that indentions actually matter.
Same with like JavaScript and such, because that shows like it's a separate line, it's further back in the code.
Can print I. And does anybody know why we have to print I and not range, or the values in range?
I is a variable.
I is the variable for this for loop, right? But in this case, it's temporary. It's not something that will be permanent. Yes. So let's run this program right now, just to test it, right? So it types escape, colon WQ, and that will write your file. That will exit out, and then if we were to run the file, we'll do Python 3 cyber.py. It's also really nice to have the whole color, because if I know that I spelled like print wrong, I'll know that print isn't highlighted orange, so I know that I spelled it wrong. But let's say I typed in that, right? I wanted to type in print, but I misspelled it. So now I'm going to write it and run it. And if I run it, you can see that I get an error. And let's break down this error. So trace back most recent call last. So that's tracing back our most recent definition of the script, and it's telling you what file that happened in at line 6. So if you guys go back to NVIM, let's go back real quick. What was the error?
It said line 3 and line 6.
So line 3 and line 6. So line 6, the reason why we got an error for line 6 is because that's
something inside of it was wrong.
Yes, something inside the function example, when we called it, that's when it happened. And line 3, that's where it stopped. That's where the error happened. So of course, if we go back, right? We go back, we can easily tell that, hey, I spelled print wrong. Let's try to fix that. And now, jeez. Yeah, if you spell it correctly, of course. Now, when we run it again, everything runs smoothly. There's one last thing that I'm going to do before we end it today, and that's going to be looking more into the internals of a program file. Okay, and to compile a C file, you do our inherited compiler GCC. You'll do the parameter -c to compile it, and then your file's name. So as you can see, example compile.o is our compile file. So I'm going to go into a program called Ghidra real quick. Do you guys remember Ghidra?
Yeah.
So that's how we're going to be able to reverse engineer our programs. And I'm going to open that example file, and we're going to look at the internals of that. Okay, so if we want to make a new project and open our example file, we have to go to New Project, non-shared, because, I mean, it doesn't matter actually, but I don't have any other users, and our project name. So I'm just going to say CyberExample. So we finish that, and then for here, you go to your folder that you're wanting, and then you have to import your file. So I have to go to import, and I'm going to do example compile.o. So we'll import that. It's going to find some things about it, and I'm going to press OK. It's going to do its thing. Eventually, it's going to ask to analyze it. So as you can see here, we can see the file's name. You can see when it was last modified, some of the language defaults, its compiler, or what kind of processor it's running on, the EDN. I'll explain all of that some other time. So obviously, we'll double click on this. Okay, double click on that, opens it up. It says, do you want to analyze it? Yes, you do want to analyze it. So you hit analyze and analyze some of this stuff. So I didn't actually look at what stuff I was actually putting in there. So I actually have no idea what our code is. But let's look at it. Let's look at it together. So as you can see, these are our address. This is where our values inside our script is being held, right? And the values to its right is assembly. And what assembly is, it's just a way to communicate to the processor and to your computer's architect to run certain commands. Because you guys can see push, move, sub, and some of this extra stuff over here. But if you can see in the green is where most of our values are actually being held right now. Here, let's see if I can. There we go. So if you guys can see over in the green is going to be mainly what seems here is as talking about entry
Writing
points.
and reading.
Oh, what?
Is that saying writing and reading with the R and W?
Yes. So R will of course be the reading and W meaning the writing. Whether it's writing or reading, I have no clue. But if you can see over at the right side, we can see that. We can see the function of this. In this bracket right here, we're able to see what this code is at, what this is detailing us. So we can see that it's calling a function, it has some parameters, some undefined parameters, and it's printing some stuff. I would assume the printing is the writing, and what it's reading the parameters. So that's how we can actually decrypt some of our compiled stuff, right? But obviously this is only a section of what we know right now. So we have generate QR code, and we're having some parameters, and it'll say generate QR code for data. It'll tell us what kind of string. So the you guys see the symbol right here, the percentage sign and S, and the percentage sign D.
Yeah.
So the percentage sign S is your string. That's how you write strings in C, right? You'll have your parameter, and that goes in place of your percentage sign C. And then D is going to be your, I believe, your undefined, right? No, that might be your decimal. Yeah. So D will be your decimal, your number, your integer, that it goes in place of. All right, so let's look at a different function that we might be able to see here. So over on the left side, you can see our functions right here in our symbol tree. So these are the functions that are going to be what our program is composed of. So right now we have two functions, our generate QR code and our main function. Our main function is how a C program is able to run. If you don't have a main function, your program's not going to be able to run. Like it's the standing point, your standard. You're going to have a C function for every C file. So if we look inside our C file, or our functions inside the C file, we can see that it has a main of generate QR code hello world, and it returns a value of 0. So this script seems pretty basic, actually. Like there's actually not a whole lot going on here. I don't even think it's actually generating a QR code, because if we look at both of these, it's just printing statements and not actually outputting anything. But yeah, that's how, if we ever have a C file that's compiled, this is how we're able to decrypt it. Here, let's go back really quick to the terminal. So everyone remember the cat command that reads the contents of a file. So if I press ls and I press cat compile .c, right, and I compile it, it tells us everything on here. So obviously we can see our generate QR code, it's printing something, and it's printing the QR code created successfully, even though it's not actually creating QR code. And then our main is the generate QR code hello world return 0. But if we were to read the contents of example.o, whoops, accidentally did CD. Okay. You can see that there's a whole lot of random values here. These values don't actually exist inside our programming language. And everyone remembers, right? This came from example compile.c. So isn't it weird that when we compile it and we actually read the contents of it, you can't actually see what the functions are, you can only see what the strings are. Generate QR code for data, size, and parentheses D. QR code generated successfully, hello world, and all that. Not only that, but you can also see some of the stuff happening here, like ELF, and what our file was created on, the Debian 13.2.0-4. If you want to get rid of a file, you have to first close your project, right? And to get rid of a project, you'll go to delete. And then you'll do your file name. The file extension is GPR, and that's the file extension used by Ghidra. So I'm going to delete that really quick, and that's that. The project's not there anymore. Okay, you can turn it off now.